prime number. What are the important key points that we discussed? A prime number is a natural number which has only two distinct factors, and the factors are 1 and itself. Any natural number which has only two distinct factors is called a prime number, and the only prime number which is even is 2. 2 is the only even prime number. And the prime number series has no particular pattern in the difference of the two consecutive numbers. So any prime number greater than 2, it is an odd number. It is of the form 2k plus or minus 1. Greater than 3, it is of the form 6k plus or minus 1. 1 to 50, there are 15 prime numbers, and 51 to 100, there are 10 prime numbers. These are some of the important concepts. All the problems whatever we did are related to anything which is an application of these important key points. 2 is the only even prime number series 2, 3, 5, 7. Any prime number greater than 3, it is of the form 6k plus or minus 1. Let us solve this problem. Few students have answered me in the WhatsApp. Now before we solve the question, now see here. First, the smallest positive value for which the fractions, there are some fraction. A fraction is of the form numerator by denominator. Denominator not equivalent to 0, and numerator and denominator are integers. Okay. Then these equations are in its simplest form. When it will be in simplest form, 2 by 4, it is equivalent to 1 by 2. 1 by 2 is in its simplest form. 2 by 4 is not in its simplest form. 3 by 6, it is not in its simplest form. 4 by 12, it is not in its simplest form. A fraction is said to be in simplest form. If the HCF of numerator and denominator, it is 1. HCF of numerator and denominator, it is 1, or in terms of mathematical language, numerator and denominator should be co-prime to each other. If numerator and denominator are said to be co-prime to each other, then the fraction is said to be in its simplest form. If numerator and denominator are in its simplest form, 2 and 4 both are even numbers. Even numbers cannot be co-prime to each other. 3 and 6 both are multiples of 3. 5 and 25 both are multiples of 5. Now if you observe, 2 is a factor of 4, 3 is a factor of 6, 4 is a factor of 12, 5 is a factor of 25. If the numerator is a factor of denominator, if it is a factor of denominator, then I am not getting simplest form. That means numerator and by denominator. If the numerator is a factor of denominator, then this fraction is not in its simplest form. Am I right? We will write some examples so that it will be clear. If the numerator is a factor of denominator, then the equation is not in its simplest form. 5 by 15, 7 by 35, 2 by 4. 5 is a factor of 15, not in its simplest form. 7 is a factor of 35, not in its simplest form. 2 is a factor of 4, not in its simplest form. So because it is not in simplest form, x plus 2 cannot take any factors of these, nothing but it cannot be a factor of 10. If it is a factor of 10, then it will not be in simplest form. It cannot be a factor of 11. It cannot be a factor of 50. If it is equivalent to factor of 10, 11, 12 and so on, then the equation is not in its simplest form. After 50, 51. 51 is nothing but 3 into 17. 3 into 17. So 3 into 17. Automatically when you are proceeding it, x plus 10, x plus 11, x plus 12, x plus 13. In 12 there is a 3 factor. In 17 there is a 3 factor. X 52, it is 2 and 26. 2 and 26. 26 will come as you proceed from 2 and 49. 2 also will come, which is a factor of the denominator. So it cannot be 51, it cannot be 52. So x plus 2 has to be 53. X is nothing but 51. X is nothing but 51. Smallest positive value for which the fractions are in its simplest form. A fraction is said to be in its simplest form. A fraction is said to be in its simplest form only when two numerator and denominator are co-prime to each other. If they are co-prime to each other, then the equation is said to be in its simplest form, HCF of numerator and denominator. Now if you see, if x plus 2 is taking factor of 10, 5. 5 is a factor of 10. 5 by 10. 5 by 5 by 10, it is not in its simplest form. If x plus 2 is taking, this can be written as x plus 2 by 10. If for confusion, this can be written as x plus 2 by 11 plus 1. This can be written as x plus 2 by 12 plus 2. And so on up to x plus 2 by 50 plus 40. Now if you see, x plus 2 cannot be a factor of 10. X plus 2 cannot be a factor of 11. X plus 2 cannot be a factor of 12. X plus 2 cannot be a factor of 50. X plus 2 cannot take any factors of 10 to 50. So if x plus 2 takes 51, 51 is nothing but factor of 51 is 3 and 17. 3 and 17 will come as a factors of the denominators. 3 is a factor of 12. 17 also will come. 52. Basically take a prime number. Take a prime number just greater than 50. Because it is the smallest positive value. Anyway, it is not taking 10 to 50. Take a prime number just greater than 50. Then the equation will be in its simplest form. If you see here, x plus 2 by 10. If I take, suppose if I take 6 by 10. 6 by 10, it is not in its simplest form. So x plus 2, it can take a prime number. 7 by 10, it is in simplest form. X plus 2 by 50. X plus 2 and 50, they both should be co-prime to each other. They both should be co-prime to each other. X plus 2 and 11, they both should be co-prime to each other. I hope the idea it is clear. Right answer is nothing but x plus 2 is a prime number just greater than 50. X plus 2 is 53. So please remember this for x plus 2. Don't tick mark 53. 53 is the value that is assigned for x plus 2. So x value will be 51. Very, very good question. A conceptual question for you to understand it clearly how it is there. Next one, P equivalent to A plus B, where A is the product of all prime numbers less than 62, 2, 3, 5, 7 and so on up to all prime numbers less than 62 till 61. B is a natural number from 2, 3 and so on up to 61. B is a natural number here. What is the question? For how many values of B? B will take how many values such that P is a prime number. Let me write down A. A is product of all prime numbers less than 62. So till 61. Plus B is either 2 or 3 or 4 and it goes on up to 61. Very, very good question. Now if you think logically, this is multiplied by 2, even number. This is 2. 2 is an even number. Even plus even, it is nothing but an even number. Are you with me? These multiplied by 3. These 3. Answer will be multiple of 3. Any multiple of 3 other than 3. It is a composite number. 4 is an even number. These also an even number. Even plus even, it is even. These multiple of 61 plus 61. Answer will be a multiple of 61. So all the numbers are multiples of either 2 or 3 or 5. And so on up to 61. So answer is no value of B. Answer is no value of b will make p as a prime number. No value of b will make p as a prime number. Very, very logical question, sir. Application oriented, non-formula oriented. If you observe, every value that b is taking, the factor of that value is present in a. 2 it is present, 3 it is present, 4 factor 2 it is present, 5 it is present, 6 factor 2 and 3 it is present. Every value b is taking, that is actually a part of a, the factors of that b. So such that no value of b exists. Good question, sir. Question number 2. We are in model number 8. 20 plus models only on prime numbers. How many values of b? P is prime number, 0 value. No value. I hope the idea it is clear. Second one, third one, another question. If p, this is an exam model question. P is a prime number. Prime number means it is a set of natural numbers. P lies from 53 factorial plus 1 to 53 factorial plus 2. So P is 53 factorial plus 2. Next it is 53 factorial plus 3. And so on it is 53 factorial plus 51. 51. These are nothing but 53 factorial is 53 into 52 and so on up to 3 into 2 into 1 plus this value can be 2, 3 and so on up to 51. This will come everywhere. Same logic what we did in the previous problem. 2 is a part of this number. Even plus even, even. Right? It is not possible. 3. This is divisible by 3. Answer is divisible by 3. Even plus even, even. 51. It is 3 into 17. 3 is present here. 17 also it is present here. Every value that it is taking, it is actually a part of factorial or its a factor. So answer is no value p can take. No value p can make it, right? No value p takes such that p is a prime number. Such that p is a prime number. No prime number values p can take. Very, very good. A cat replica question, sir. This is the beauty of CAT examination. Most of them are logical questions. 53 factorial plus 2 factor plus 3 plus 51. Divisible by 2, divisible by 3, divisible by 51. Because in 53 factorial, 3 will come, 17 will come. Third question, I hope it is clear. Next one. For how many positive integers is the cubic expression is n cube minus 8n square plus 20n minus 13. For this has to be a prime number. This has to be a prime number. How many natural number values n will take? Now if you see here, if you see, first write down the concept. First see the concept. If the sum of the coefficients, if the sum of the coefficients in p of x, if it is equivalent to 0, then n minus 1 is a factor. Then n minus 1 is a factor. Then n minus 1 it is a factor. So let us see coefficient of n cube 1 minus 8 plus 20 minus 13. 21 minus 21, 0. That means n minus 1 is a factor of p of x. N minus 1 is a factor of p of x. So these is nothing but n cube minus 8n square plus 20n minus 13. N minus 1 it is a factor. There is one more factor b which is nothing but quadratic because it is cubic, linear it is 1. So b has to be a quadratic function. So let us find out what is q of x. Sum of the coefficients in p of x, if it is equivalent to 0, then n minus 1 is a factor. Sum of the coefficients if it is 0, then n minus 1 it is a factor. I hope this first concept is clear. Now let us see. N cube minus 8n square plus 20n minus 13. Step number 2. I am using synthetic division to get the remaining q of x. What is the synthetic division? Let us see. Synthetic division helps us in giving the quotient. These n cube minus 8n square plus 20n minus 13, it is divided by n minus 1. I need the quotient and I need the remainder. So by using this synthetic division, quotient and remainder can be obtained. How it is obtained? Write down the coefficients in serial order. 1 minus 8, 20 minus 13. n minus 1, it is a factor. Put it equivalent to 1. So start with 0. 1 plus 0, 1. Cross multiply. Minus 8 plus 1, minus 7. This is minus 7. 20 minus 7 is 13. 13 ones are 13. This is nothing but 0. This is the remainder 0 and this is nothing but the quotient. That means this entire expression, it is nothing but n minus 1. Quadratic divided by linear, remaining is, cubic divided by linear, remaining is quadratic. N square minus n plus 13, 7n plus 13. I hope it is clear how these cubic is converted into linear into quadratic. Sum of the coefficients in p of x, it is equivalent to 0. So n minus 1 is a factor. Remaining, it is nothing but. To determine synthetic division helps us in determining the quotient as well as remainder. Quotient as well as remainder. Now see here. This is nothing but n cube minus 8n square plus 20n minus 13. It is nothing but n minus 1 into n square minus 7n plus 13. So if it is p equivalent to a into b, if I can write it as only two factors, one and the number itself, 1 into p and p into 1, then p is called a prime number. A prime number has got only two distinct factors, that is 1 and itself. A prime number has got only two distinct factors, 1 and itself. So either a can be 1 or b can be 1. Case number 1. Either n minus 1 equivalent to 1 or case number 2. The second number can be 1. N square minus 7n plus 13 equivalent to 1. So these n square minus 7n plus 12 equivalent to 0. These is nothing but n minus 4 into n minus 3 equivalent to 0. N is nothing but 3 comma 4. So n can be 3 comma 4 or n can be 2. N can be 2. So three values it can take, n2, n3, n4. For these three values, this cubic expression is a prime number. Cubic expression is written as product of two factors, that is n minus 1 into n square minus 7n plus 13. If this number is a prime number has got only two distinct factors, 1 and itself. So 1 into p or p into 1. Either n minus 1 can be 1 or n square minus 7n plus 13 can be 1. Two cases, case 1 or case 2. You can take any two cases, you will get the answer. These n equivalent to 2 or n equivalent to 3 and 4. I hope the idea it is clear. Each and every question, please listen carefully, sir. X is n power 4. See, always remember, if p is a prime number, you should write it as 1 into p or p into 1. If you are able to write it like this, then p is considered to be a prime number. A prime number has only two distinct factors. First one, x equivalent to n power 4 plus 4 power n. Right? N power 4 and 4 power n. This is nothing but a prime number. Listen carefully. Prime number means I need to write it as a product of two factors. This is n square whole square. This is 2 power n whole square. 2 power 2n. A square plus b square. A square plus b square is nothing but a plus b whole square minus 2ab. So this is nothing but n square plus 2 power n whole square minus 2ab. 2 into 2 power n into n square. 2 power n into n square. These are nothing but n square plus 2 power n whole square minus n square into 2 power n plus 1. Minus n square into 2 power n plus 1. Case number 1. Case number 1. If I take n value even, this will become x equivalent to even plus even. Even plus even, it is an even number. It is an even number. Other than 2, there is no even number which will make the x value prime number. So, even anyway, it is out. Case number 1. Case number 2. If n is odd, any odd number can be written of the form 2k plus 1. Now, if you observe, these are nothing but 2k plus 1 whole square plus 2 power 2k plus 1 whole square. These 2k plus 1 whole square into 2 power 2k plus 1 plus 1, 2k plus 2. So, 2 power k plus 1 whole square. Am I right? So, these are nothing but 2 power 2k plus 1 plus 1. 2k plus 2 can be written as 2 into k plus 1, which is 2k plus 1 whole square. A square minus b square. Both of them is not giving me 1. So, answer is x is a composite number. X is a composite number. 2k plus 1 whole square. 2k plus 1 plus 2 power 2k plus 1 for x and y. Now, if you see, suppose for example, if I take n value odd, n is an integer greater than 1, 3. 3 power 4 plus 4 power 3, 81 plus 64, 145. Like that. None of them, it is a square minus b square, a plus b into a plus b. Even if you take k value 0, you are not getting 1. Put k value 0, these is nothing but 2 square. 2 square is 4. 4 square 16 minus k value 0, it is 1 into minus 2 square 4. 16 minus 4. You are not getting anywhere. So, answer is x is a composite number. I hope the idea it is clear. All are very, very good questions, sir. X is a composite number. Why it is a composite number? If n is an even number, x is becoming an even number. Even number, it is not possible. If n is an odd number, it cannot be expressed as 1 into p or p into 1. Both the cases, it is not possible. So, x is a composite number. X is a composite number. X and y both are prime. X is composite. X is composite. First option and second option, it is out. Now, let us see the y value. Y is nothing but n power 4 minus 20 n square plus 4. This can be written as n power 4 minus 4n square plus 4 minus 16 n square. These is nothing but n square minus 2 whole square. 16n is 4n whole square. A square minus b square. A plus b into a minus b. N square minus 2 minus 4n. Are you all with me? Case number 1. It can be written as either 1 into p or p into 1. Two cases. N square minus 2 plus 4n equivalent to 1. N square plus 4n minus 3 equivalent to 0. Factorize this one. So, 3, 16 plus 12, 28 greater than 0. Case number 2. If it is n square minus 4n minus 2 equivalent to 1, this is nothing but n square minus 4n minus 3, minus 3 only, right? So, n square equivalent to 0. If you get any values of n, write, substitute and check. If you are not getting, then x and y are composite. I hope the idea it is clear. So, write these expression as any prime number. If you want to do it, write these expression as a plus b into a minus b. Write it as 1 into p or p into 1. 1 into p or p into 1. Either this value will be 1 or this value will be 1. check if you are getting any integral values. If you are not getting it, then right, then probably this is not a prime number. Just solving the equation because of space constraint, I am leaving it for you. I am sure you can solve it. I hope the idea it is clear. This is a very, very good question, sir. Extremely good question. First one, x equivalent to 20, forget about it. It is nothing but n power 5 plus n power 4 plus 1. This can I write it as n power 5 plus n power 4. I will add n cube, I will subtract n cube. I will add n square, I will subtract n square. I will add n and I will subtract n plus 1. You will come to know why am I doing this. If I take n cube common, this is n square plus n plus 1. If it is, again, if I take n common, n square plus n plus 1. I hope it is clear from where I am taking this value, and this value. I am taking minus n common, n square plus, what is remaining? N square plus n plus 1. N square plus n plus 1 if I take common, this is nothing but n cube minus n plus 1 into n square plus n plus 1. It cannot, it is, both of them is not giving me one value, right? Because n is an natural number. If n is a natural number, 1 plus positive, it will be positive. It cannot be 1. If n cube minus n plus 1, if it is 1, n into n square minus 1, it will be 0. That is also not possible. Very, very important concept. N power 5 plus n power 4 plus 1. Any number which is of the form n power 5 plus n power 4 plus 1, this number is a composite number. Any number which is of the form n power 5 plus n power 4 plus 1, neither this can take 1 because 1 plus positive, how can I get 1 plus positive? I cannot get 1. Or if I take the first one, 1. Right, n cube minus 1, n cube minus n, it is plus 1 equivalent to 1. N into n square minus 1 equivalent to 0. N square minus 1 is n minus 1 into n plus 1. Product of 3 natural numbers, it cannot be divisible by 0. So neither it can be 1 nor it can be 1. So definitely this number is composite. N power 5 plus n power 4 plus 1. Any number which is of the form n power 5 plus n power 4 plus 1, it is composite. Please make a note of it. N power 5 plus n power 4 plus 1. This is a composite number. So x is a composite number. X cannot be prime. X cannot be prime. First and second are out. Next one. These nothing but y equivalent to, take the first and the last, 16 power 8 minus 1, minus of 16 cube. These 16 cube, 16 square, 16, or we will write it like this, so that in a we can reduce the step. I will take the first and third. Y is 16 power 8 minus 16 power 3. These are nothing but minus 16 power 5 minus 1. 16 power 5 minus 1. Now see here. These are nothing but 16 power 3 if I take common. 16 power 5 plus 1. If I take minus 1 common, 16 power 5 plus 1. 16 power 5 plus 1. Now if you observe, these are nothing but 16 power 5 plus 1 into 16 cube minus 1. Into, that means already we discussed a power n plus b power n. It is always divisible by a plus b if n is an odd number. If n is an odd number, a power n plus b power n is always divisible by a plus b. So this is always divisible by 17. Any number divisible by 17, it becomes a composite number. Very, very good problem, sir. Very good problems. Answer is composite. So x and y both are composite. I hope the idea it is clear. Answer is both are composite. Clear, right? Idea? Suppose if x and y both are composite. Suppose if in case if you want to do like this, for example, if there is a question, for example, if there is a question 1041, is 1041 prime or composite? Is 1041 prime or composite? It can be written as 1024 plus 16. These 1 minute, sir. What I'll do is these, for example, 4 power 4, right? 4 power 4 is 256. 256 plus 1, 256 it is 1281. Let us take 1281. I'll tell you what am I trying to tell you. Is 1281 prime or composite? One is find out the square root of 1281. Other thing is, can I write it as 1024 plus 256, which is 1280 plus 1. These are nothing but 4 power 5. These are nothing but 4 power 4 plus 1. Just now we have seen n power 5 plus n power 4 plus 1. Any natural number n can take. These are nothing but a composite number. These are nothing but a composite number. So 1281, it is composite. Anyway, this number is divisible by 3. Anyway, this number is divisible by 3. I hope the idea it is clear, right? 1281, 8 plus 1, 9, 9 plus 2, 11, 11 plus 1, 12. You can also write it like this. N power 5 plus n power 4 plus 1. So answer is x and y both are composite. X and y both are composite. You can do it as 243 plus 81 plus 1. Suppose if the question is 325, it is ending with 5, so it is a composite. Or 3 power 5, 3 power 4 and 1. N power 5 plus n power 4 plus 1. The number is always a composite number. Number is always a composite number. Now see, consider the following numbers. Which all the numbers are prime numbers or composite numbers? So these are nothing but 243 into. How many digits are there after 243? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is into 10 power 10 plus 81 into. How many are there? 10 power 8 plus 1. This is the number. This is nothing but 3 power 5 into 10 power 10. It is nothing but 3 power 4 into 10 power 8 plus 1. This is nothing but 3 into 10 square power 5. This is nothing but 3 into 10 square power 4 plus 1. 3 into 10 square it is n. N power 5 plus n power 4 plus 1. N power 5 plus n power 4 plus 1. The number is always a composite number. See how beautifully the larger numbers can be used to find out whether it is composite or prime. N power 5, what is model number 10? New logic. Any natural number which is of the form n power 5 plus n power 4 plus 1, it is always a composite number. So answer for this question is, this is a composite number. This is a composite number. So first one we got it as composite. Answer for this question is composite. Y. Y is nothing but 2 power 58 plus 1 divided by 5. So this can be written as 2 square power 29 plus 1 power 29. 2 square power 29 or 1 power 29 or, so that means it is divisible by 5. So numerator it is divisible by 5. I hope it is clear. So this entire number is perfectly divisible by 5. So it will become a multiple of 5. If it becomes a multiple of 5, then this is nothing but a composite number. These are nothing but a composite number. 2 power 58 is 2 square power 29 plus 1 power 29. A power n plus b power n. It is always divisible by a plus b if n is an odd number. A cube plus b cube is a plus b into a square minus ab plus b square. So it is perfectly divisible by 5. That means if it is 5 into 5, these 5 into 5. Now we have to check whether x could be a prime number. If that is the question that is popping up in your mind, then these nothing but 2 power 29 whole square plus 1 whole square. These nothing but a square plus b square, which is nothing but a plus b whole square minus 2ab. So these nothing but 2 power 29 whole square plus 1 square. These nothing but 2 power 29 plus 1 whole square minus 2 into 2 power 29. This is 2 power 29 plus 1 whole square minus 2 power 30. So it is 2 power 15 square. A square minus b square is a plus b into a minus b into a minus b. For it to be a prime number, either it should be 1 into p or p into 1. 1 plus positive, it is greater than 1. 1 plus positive 2 power 15 is very small, it cannot be 1. So answer is, it is composite. I hope the idea is clear. First we checked for the numerator 2 power 58 plus 1 is divisible by 5. But the question is 2 power 58 plus 1 divided by 5. I hope the idea it is clear. So numerator itself it is composite. Now if you divide by 5, you will get some value. That value cannot be a prime number. I hope the idea it is clear. That value cannot be a prime number. So divide 2 power 29 plus 1 plus 2 power 15 divided by 5. Use a negative remainder and try to solve. Idea clear? Next one. Z equivalent to 5 power 12. Z equivalent to 5 power 12 plus 2 power 10. This is nothing but 5 power 6 whole square. This is nothing but 2 power 5 whole square. A square plus b square is a plus b whole square. 5 power 6 plus 2 power 5 whole square minus 2ab. 2 into 5 power 6 into 2 power 5. These is nothing but 5 power 6 plus 2 power 5 whole square minus, it is 2 cube into 5 cube whole square. 2 power 6 and 5 power 6. A square minus b square is a plus b into a minus b. None of them is giving you 5 power 6 plus 2 power 5 plus 2 cube into 5 cube, or 5 power 6 plus 2 power 5 minus 2 cube into 5 cube. This is not giving me 1, these are not giving me 1. Composite, composite, composite. Proving that a prime number is a prime number is a very complicated problem, because it has to go through 237 layers. Every layer it has to fail. If all of them fails, then the number is a composite number. I hope finish off entire prime numbers today. All XYZ are composite. All XYZ are composite. We are at model number 10. I hope the idea it is clear. Model number 11. How many numbers less than or equivalent to 500? Number should be less than or equivalent to 500 are there, which is the product of more than 3 distinct prime numbers. Product should be more than 3. So let me start with 4. A1 into A3 into A4 less than or equivalent to 500. It can also be A1 into more than 3, right? So it can be A1 into A2 into A3 into A4 into A5 less than or equivalent to 500. Let me see. All the numbers are distinct. All the numbers are distinct. If I take 5, 2, 3, all of them are distinct. Into 7 into 11. 6 5s are 30. 30 11s are 330. Into 7, 2000. So these more than 4 case will not come. I hope it is clear. Sum is, it is getting into greater than 500. Now, 4 numbers we have to take. So, it is 2, 3, 5, 7. Let me see if the product is less than 500. 6 5s are 30, 37s are 210. These perfect. Next one, 2, 3, 5. Let me take after 7. What is the next number? 11. 30 into 11, 330. These also perfect. Let me take the next number. 13. 6 5s are 30, 13s are 390. It is also perfect. Next it is 2 into 3 into 5 into 17. 30 17s are 510. It is not possible. 3 cases came here. Next it is 2 into 3. Instead of 5, I will keep 7. After 7, what is the next prime number? 11. 2, 3, 7. 7 11s are 77. 77 3s are 231. 231 into 2. 462. This is also a possible case. Next case, if I take 2 into 3 into 7 into 13. 13 2s are 26. 3s are 78. 78 into 7. It is greater than 500. How many cases we got? 1, 2, 3, 4. 4 cases we got. There are 4 distinct prime numbers whose product will be less than or equivalent to 500. Idea, it is clear. If you go slowly, step by step, you will keep getting the answer. Now, a 3-digit, this is what I said, some of the exams were previously to get into IIMs. There used to be another examination. This was way back 20 years before. A 3-digit natural number is written side by side, n equivalent to ABC, ABC. Any 3-digit number, what is the concept that we discussed? Any 3-digit number written even number of times. Any 3-digit number written even number of times. It is always divisible by which all numbers? It is always divisible by 7, 11, 13. In my previous class, I discussed this concept. So, n is perfectly divisible by 7, 11 and 13. Any 3-digit number written even number of times, it is always divisible by 7, 11, 13. Next one, number of positive integers such that n minus 1 factorial is not divisible by n. This is another very conceptual question, sir. N minus 1 factorial is never divisible by n. N minus 1 factorial is never divisible by n. When there are 2 cases that is possible. When n is a prime number and n equivalent to 4. When n equivalent to 4 also, n minus 1 factorial is never divisible by n. N is a prime number. You can check it out. N equivalent to 3. 3 minus 1. 2 factorial. It is 6. 6 is never. N is 3. 3 minus 1. 2 factorial, which is 2. 2 is never divisible by 3. If n is 5. 5 minus 1. 4 factorial. 24 is never divisible by 5. So, n minus 1 factorial is never divisible by n when n is a prime number and n equivalent to 4. What are all the prime numbers from 12 to 40 possible? 13 is a prime number, 17 is a prime number, 19, 23, 21, 31, 37 and n equivalent to 4. 1, 2, 3, 4, 5, 6, 7, 8. Total 8 values n can take such that n minus 1 factorial is never divisible by n. Previous year CAT question, sir. N minus 1 factorial is never divisible by n when n is a prime number and n equivalent to 4 and n equivalent to 4. Another conceptual question. Concept. Very, very important concept, sir. If x is a prime number, if x is a prime number, if x is a prime number, a power x minus a is always divisible by x. A power x minus a, it is always divisible by x. A should be a natural number. If x is a prime number, a power x minus a, it is always divisible by x if a is a natural number. If x is 3, 3 is a prime number, 2 cube minus 2, 8 minus 2, 6. 6 is perfectly divisible by 3. If x is 4, 4 power 5 minus 4, this is nothing but 1024 minus 4, which is 1020. 1020 is perfectly divisible by 5. Very, very important key point. Very, very important key point. If x is a prime number, a power x minus a, it is always divisible by x if a is a natural number. If a is a natural number. Now we will use that concept. The question is 29 power p plus 1. This can be written as 29 power p minus 29 plus 30. I hope it is clear. 30 is divisible by 2, 3 and 5. These are the prime factors. These are nothing but 29 power p minus 29. These is divisible by, right? These is perfectly divisible by p if p is a prime number. P is a prime number. So p can take 2, p can take 3, p can take 5. So these prime factors are 2, 3 and 5. So entire number should be divisible by p. Entire number should be divisible by p. So these divisible by 2, 3 and 5. Is these divisible by 2, 3 and 5? Definitely yes. Because if x is a prime number, a power x minus a, it is always divisible by x. A power x minus a, it is always divisible by x. So p can be a prime number. What? How many values? 2, 3, 5. This number divisible by 2, 3, 5. This number, check it out whether it is divisible by 2, 3, 5. Definitely it is divisible by 2, 3, 5. Why? Because of the concept, if x is a prime number, a power x minus a, it is divisible by x. Model number 15. In your online classes, you check it out how many problems will be solved on prime numbers. It is the 4th session on prime numbers. In the 4th session, 22 models I am discussing. Next one. Find the largest integer that always divides n power 7 minus n. N power 7 minus n. This is nothing but a power x minus a. It is always divisible by x if x is a prime number. If x is a prime number and a is a natural number. This is the concept. N power 7 minus n. It is perfectly divisible by 7. Lowest integer that will divide this number is 7. But the question is the largest integer. So this can be written as n into n power 6 minus 1. N into. These are nothing but n cube whole square minus 1 whole square. These n cube minus 1 into n cube plus 1. N cube minus 1. It is, or we will write it as n square whole cube minus 1 cube, so that we will get some more factors easily. You write it as n square whole cube. These you can write it as this. It is n square whole cube minus 1 whole cube. A cube minus b cube. It is n into n minus 1 into n square whole square plus n square plus 1. Now if you see, n square minus 1 is n minus 1 into n plus 1. N into n minus 1 into n plus 1. These are all three consecutive numbers. Three consecutive numbers. It is always divisible by 6. These three consecutive numbers are divisible by 6. This number is divisible by 7 because the power is a prime number. So answer is divisible by 7 and 6. Remaining is 42. These is nothing but n power 4 plus n square plus 1. These is nothing but x square plus x plus 1. X square plus x plus 1. D is less than 0. Discriminant less than 0. Roots are imaginary. So only this needs to be considered. N minus 1, n plus 1. Three consecutive. It is divisible by 6. This number is divisible by 7. So answer should be divisible by 42. Answer should be divisible by 42. Model number 15. Right after the class is over, please sit and watch the entire class. Another good question. What is the largest prime number whose cube divides? So the question is 1 factorial into 2 factorial into 3 factorial and so on. 997 factorial, 998 factorial, 999 factorial, 1000 factorial and 1001 factorial. Largest prime number. So 1001 is not a prime number. 7 into 11 into 13. 1000 even number, not possible. 999 divisible by 9, not possible. 998 even number. So let me check whether 997 is prime or composite. How to check it out? 997. Square root of 997. 31 square is 961. 32 square is 1024. Take all the prime factors less than or equivalent to 31. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31. So check if 997 is divisible by any of these numbers. If it is not divisible by any of these numbers, then 997 is a prime number. 2 not possible. 3 sum of the digits should be divisible by 3. 5 not possible. 7 4s are 98. 17 not possible. Sum of odd and sum of even not matching. 13 7s are 91, 87 not possible. 17 5s are 85 not possible. 19 5s are 95 not possible. 23 4s are 92, 57 not possible. 29 3s are 87, 127 not possible. 31 3s are 93, 67 not possible. It is not divisible by any of the prime numbers less than square root of n. That means 997. It is a prime number. Because it is the largest, I am coming from 1001 onwards, going back. 1001, 1000, 999, 998. It is not possible. So 997, it is possible. Cube right? That means in 997 factorial, 997 into 996 factorial. Once it will appear. 998 into 997 into 996. Once it will appear. Here also once it will appear. Once it will appear. Once it will appear. So how much will be the power of 997? Power 5. 997 power 5. Is it divisible by 997 cube? Yes. So answer is, what is the largest number that divides this number? Prime number 997. Good question. Because it is the largest prime number, start from the highest. 1001, 1000, 999, 998 all are out. 997. 997 factorial contains 1 power of 997. 998 factorial. 998 into 997 factorial. 1 power, 1 power, 1 power, 1 power, 1 power. Total 5 powers are there. If the power is greater than or equivalent to 3, then it will be divisible by 3. Then it is divisible by 3. Answer is nothing but 997. Good question. Every problem that we are solving today, right, all are advanced model problems. Kindly solve it again and again. This is also a beautiful question. Both the roots of the quadratic equation x square minus 43x plus k equivalent to 0. Both the roots are prime numbers. Sum of the roots, it is given by minus b by a. For the quadratic expression, ax square plus bx plus c equivalent to 0. So alpha plus beta is minus of minus 43 and the product of the roots is c by a. It is k. 43, it is an odd number. Now if I take two odd primes, Odd plus odd, it will result in an even number. Not possible. Even plus odd can only give me odd. Even plus odd can only give me odd. Alpha is an even number. The only even number it is 2. So the next case is nothing but 41. Product of the roots is nothing but k. So k is nothing but 82. K is nothing but 82. Sum of the roots, it is 43. So if alpha plus beta equivalent to 43. 43 is an odd number. Alpha and beta both are prime numbers. Odd plus odd, it is even. Both of them cannot be odd. Even plus even, not possible. One has to be even, another has to be odd. So the only even case that is possible is alpha 2 and beta 41. Product of the roots is 2 into 41, which is 82. Idea clear? Next, beautiful question, sir. For how many positive integers between 1 and 1000 is this expression, polynomial expression, 4x power 6 plus x cube plus 5 divided by 7? For how many values from 1 to 1000 is this expression divisible by 7? Seems like a very complex question, but we will go very slowly and understand the concept in detail. Suppose if it is, let me take x power 6 divided by 7. X power 6 divided by 7. When you divide any number by 7, what are all the possible reminders? 0, 1, 2, 3, 4, 5, 6. Am I right? These are all the possible reminders. X by 7. So let us do power 6. When you divide x by 7, the remainder can be 0, remainder can be 1, remainder can be 2, remainder can be 6 till 7. I hope it is clear. So when you do 0 by 7, it is 0. 1 by 7, 1. 2 power 6 is 64. 64 by 7, it is a remainder 1. 3 power 6. 3 cube whole square divided by 7. 27 by 7. 7 4s are 28. Minus 1. Minus 1 square, it is 1. 4 power 6. 4 cube whole square divided by 7. It is also 1. 5 power 6 divided by 7. 5 by 7 minus 2. Minus 2 power even plus, it is again 1. 6 power 6 divided by 7. Again it is 1. So remainder 1, very important concept. Remainder 1, x power 6 divided by 7 will always give you values either 0 or 1. X power 6 when divided by 7, it will always give value either 0 or 1. This step I hope it is clear. Directly you can tell 0 or 1 by using Fermat's theorem, which I don't want to discuss it right now. Remainder 1, x power 6 divided by 7 is 0 or 1. Now see here. Remainder, you take any number when divided by 7 power 6, I got remainder 0 or 1. But the question is 4x power 6. 4x power 6 divided by 7, it is 0 or 4 1s are 4. If it is x power 6 divided by 7 is 0 or 1, x cube by 7. X cube whole square is x power 6. So it can be 0, 1 or minus 1. Think logically. X cube by 7, if it is minus 1, square it, it will become x power 6. Minus 1 square is nothing but plus 1. I hope the idea it is clear. So these nothing but x cube by 7 is nothing but 0, 1 or minus 1. Now if you add it, these nothing but 4x power 6 plus x cube plus 5 when divided by 7. Are you getting a remainder 0 anywhere? First case 0. 0 plus 0, 0. 0 plus 5, 5. 5 divided by 7. It is not equivalent to 0. This case not possible. 0 plus 1, 1. 1 plus 5, 6. 6 is not divisible by 7. This case out. 0 minus 1. Minus 1 plus 5. 4. 4 is not divisible by 7. This case not possible. 4 plus 0, 4. 4 plus 5, 9, not divisible. 4 plus 1, 5. 5 plus 5, 10, not divisible. 4 minus 1, 3. 3 plus 5, 8, not divisible. No value of x will satisfy these expressions. Very, very good question. Seems like a complicated question, but if you go step by step, there are good chances that you will get the answer. Just with a little carefulness you have to do it. These x power 6 divided by 7 is 0 or minus 1. X cube whole square is x power 6. So a square is 1. This will be 1 or minus 1. This will be 1 or minus 1. Just I added 0 plus 0 plus 5, 5. 5 divided by 7, remainder not 0. 1 plus 5, 6, not divisible. None of them is giving you remainder 0. Good question. Model number 18. You don't need to refer any textbook other than my course. The most comprehensive content. Next one. For each positive integer such that f of n is degree 4 is given. N power 4 minus 360 n square plus 400. For how many values of n? That f of sum of the values such that f of n it is a prime number. So what you do is, this you write it as, what is the concept of a prime number? Write down as a product of two factors, 1 into p or p into 1. 1 into p or p into 1. Only two distinct factors, 1 and itself. So these are nothing but n power 4 plus 40 n square plus 400 minus 400 n square. These are nothing but n square plus 20 whole square minus 20 n whole square. Are you all with me? These are nothing but n square plus 20 plus 20n into n square plus 20 minus 20n. N square plus 20 minus 20n. I hope 1 into p or p into 1. Already we did it. Once you get the idea, the most complex questions will also become easy. 1 into p or p into 1. Case number 1. Case number 1. N square plus 20 plus 20n equivalent to 1. So n square plus 20n plus 19 equivalent to 0. So n will be right. So it is n plus 1 n plus 1 into n plus 19. So n will be minus 1 minus 19. Minus 19. These is not possible. Right. So why? Because for positive integer it is specifying. Next case, n square plus 20 minus 20n equivalent to 1. N square minus 20n plus 19. So n equivalent to 1 and 19. N equivalent to 1 and 19. I hope the idea it is clear. What is the sum of the values of f of n such that, what is the sum of the values such that f of n is a prime number? N whatever values you got, add it. Only thing you should get this idea as, write down it as product of two factors, which is 1 into p or p into 1. N square plus 20 plus 20n is 1 or n square plus 20 minus 20 is 1. If you are getting negative, please eliminate it because the question is a positive integer. I hope the idea it is clear. Seems like a difficult question, but actually easy question. Now another concept, model number 20. Reminder when a power p minus 1 divided by p, it is 1 when a and p are co-prime. When a and p are co-prime and p is a prime number. And p is a prime number. So this can be written as, according to this theorem, 5 power 30 divided by 31, it is nothing but 1. P is a prime number. 5 power 30 by 31. Now the question is 5 power 30 plus 30 divided by 31. 5 power 30 by 31, 1. 1 plus 30, 31. Perfectly divisible. So n value has to be 30. N value has to be 30. 5 power 30 divided by 31, it is nothing but 1 according to Fermat's theorem. According to Fermat's theorem, 5 power 30 divided by 31, it is 1. So next one, 1 plus 30, 31, n equivalent to 30. This is a learning from this problem. Next one, what is the remainder of 1 into 1 factorial, 2 into 2 factorial, 1000 into 1000 factorial divided by 2002. 2002 is nothing but 2 into 1001. First step. This is nothing but summation n into n factorial. N is ranging from 1 to 1000. This can be written as n equivalent to 1 to 1000. N can be written as n plus 1 minus 1 into n factorial. This is nothing but n equivalent to 1 to 1000. N plus 1 into n factorial. N plus 1 factorial minus n factorial. That means 2 factorial minus 1, 3 factorial minus 2, 1001 factorial minus 1000 factorial. All will be eliminated. The finally that is remaining is 1001 factorial minus 1. 1001 factorial minus 1. So these is nothing but remainder 1. 1001 factorial minus 1 divided by 2 into 1001. 1001 factorial contains 1001 and 2. It is out. Negative remainder minus 1. Positive remainder will be 2002 minus 1. 2001. Answer is 2001. I hope the idea it is clear. Writing down this as this expression, it is nothing but n plus 1 factorial minus 1. N plus 1 factorial minus 1. 1001 factorial minus 1. 1001 factorial minus 1 by 2 into 1001. So 1001 factorial contains 2 and 1001. Negative remainder minus 1. Positive remainder 2001. Idea clear? Next one. A and B are integers. A square minus B square equivalent to 2003. This is A plus B into A minus B. 2003. First we will check whether it is a prime or composite. Now before checking, let us play around with the answer option. Assume that it is a prime number. There is no answer, none of these. So it is 2003, it is 1. 1 into 2003. These illogical. Sum of two integers, positive integers. Sum of two natural numbers is always greater than the difference between the natural numbers. That means A plus B, it is 2003. A minus B, it is 1. So 2A equivalent to 2004. A is 1002 and B is 1001. A is 1002 and B is 1001. Now A square plus B square, these 1002 square plus 1001 square. 4 plus 1, 5. Answer unit digit should be 5. All the options are eliminated. 2200, 6005. Or you can use a digital sum. 1 plus 2, 3. 3 square is 9. 9 plus 4, 13. 1 plus 3, 4. 8 plus 5, 13. 1 plus 3, 4. Answer is option A. If it is a composite number, I would have got some other answer. There is no option of A and B or none of these. So I went ahead with prime number. You can also cross check. 2003. It is closer to 45. Write all the prime numbers less than 5, 7, 11, 13, 17, 19. Check it out. Don't waste your time because answer option does not have A and B like that. Otherwise, there is a case that we would have got multiple cases. This is not possible. Idea clear? Next one. Let A, B, C, D be distinct prime numbers such that 2A plus 3B plus 2A plus 3B plus 5C plus 7D, it is 162. 11A plus 7B plus 5C plus 4D, it is both 162. Given that ABCD equivalent to K, how many distinct values K will take? ABCD are distinct prime numbers. Suppose if I subtract 11A minus 2A, 9A, 7B minus 3B, 4B, 4D minus 7D, minus 3D, equivalent to 0. These 9A plus 4B, it is nothing but 3D. Am I right? These divisible by 3. This is divisible by 3. So B should be divisible by 3. B should be divisible by 3. I hope it is clear, right? So what we will make is, we will make a slight change so that we will get the value. Suppose see here, this is nothing but 4B equivalent to 3D minus 9A. That also will give you the answer. Just reduce in the number of steps. 4B equivalent to 3 into D minus 3A. 3 into D minus 3A. Now if you see here, this entire number is divisible by 3. B should be divisible by 3. Same thing we got. If B is divisible by 3, if B is 0, 0 into anything 0, that means D minus 3A will be 0. That means D and A will be 0. But A, B, C, D are prime numbers. Don't forget these basic point. A, B, C, D are distinct prime numbers. Now we will write down here 4B equivalent to 3 into D. This is the equation we got. Now what is that we are discussing? Is a divisible by 3 number which is divisible by is nothing but 3. All are composed. 4 3s are 12. 12 equivalent to 3 into D minus 3A. Minus 3A, nothing but 4. D nothing but 4. You see here, if the number even into even, odd, even number, even plus even, even, D will be even. This is not possible. A has to be odd. Odd into odd, odd, odd plus even, odd. A will be odd and D will be odd. A is odd and D is odd. So 2 cannot be possible. 3 already given. Suppose if I take A value 5. If I take A value 5, what will be the answer? 3 7s are, 3 5s are 15. D will become 15 plus 4, 19. D value, it is a 19. 19, it is a prime number. This is one case. If A is nothing but 7, 7 3s are 21. D value 25. This is anyway not possible. Why? Because D is a prime number. Next one. If A is 11, 11 3s are 33 plus 4, 37. D value 37. If I keep D value 37, 7 into 37, it is exceeding 162. None of the cases it is possible. Easy question. A value 5. D value 19. A5, D19, B3. Now we will easily get C if I substitute. 2 into A is 5. So 2 into 5, it is nothing but 10. I will write here. 2 5s are 10. 3 into B, 3 3s are 9. 5 into C, we require C. 7 into D, 7 into 19, which is 133, equivalent to 162. 5C plus 152, equivalent to 162. 5C equivalent to 10. C value is nothing but 2. C value is nothing but 2. So C is 2, 2, 3, 5, 19. All are prime numbers. How many values it can take? Only one value it will take. What is that value? It is nothing but, A is nothing but 5. Seems like a complex question but very easy. B is 3. C is nothing but 2. And D is nothing but 19. D is nothing but, K value is nothing but 570. So one value only it is taking. I hope this idea it is clear. D is one model. D is model number 22, model 21, model 19, 18, 17, 16, 15, 14, right? Model 12. Is there any model that is missing? Let us see. So I think one model which we already covered, that was 10. It is 9, 8, 7, 6, 5, 4, 4, 3, 2, 1. What is model number 13 is? Model number 13 are nothing but the type 1. What is this type 1? Wilson's theorem. Already we have done various problems related to Wilson's theorem. Type number 2, it is nothing but divisibility rule of a prime number. These also in session number 2 we discussed in detail divisibility rule of a selected prime numbers. 7, 11, 13 we discussed. 37, 27 we discussed. 19, 101, 99, 101 we discussed. 17 and 19 we discussed. Divisibility rule of any prime number also we discussed. I hope it is clear. All